Hold on a second, let me just, okay. Hello, I'm Allison Sapala, and I'm presenting on the psychoacoustic phenomenon known as Dutch's mysterious melody. So some things that are really important for this kind of illusion is how we hear. So how we hear is our brain receives different information, and we process those sounds differently depending on like how our eardrums are like prepared and how our like damage and stuff like that has been done to that. So eardrums, they move with change in air pressure, and they also, we hear frequencies, very vast frequencies. So 20 hertz to 20,000 hertz, that's like our range. And then the brain can also detect those differences. So if you're hearing something really low pitched, you can tell that it's low versus when something's really, really high pitched, such as voices and stuff like that. And then also the sequence of pitch defines a melody. So if you're listening to a song and you're hearing like high and then like a lower like pitch, then you can like determine a melody out of like understanding how those pitches go in line and how they're sequenced. So the octave illusion itself, so a melody contour is important for identifying melodies. And a melody contour is a sequence of ups and downs that happen in a musical melody of any sort. And so in Doling and Fujitani, they had participants recognize or try to recognize distorted versions of old folk songs and stuff like that, such as Twinkle Twinkle Little Star, Auld Lang Syne, Yankee Doodle, and Oh Susanna. And they basically asked them to try to identify these without giving them any context. And then they noticed that from whether the individuals knew of that memory of that song from their past, then they were able to try to detect it a little bit better than individuals who have never heard it. So like Auld Lang Syne, like a lot of people don't necessarily know that tune, so it was a lot more difficult to like recognize that tune than it was for, say, Twinkle Twinkle Little Star or different things like that. So Dutch, she was actually the creator of the psychoacoustic phenomenon of mysterious melody, and she basically organized that octave generalization is used in recognizing tunes. And so basically that means that octave generalization is that notes were scrambled between many different octaves, and by octaves, those are like kind of like jumps. So there's notes from A to like G in the scale, and then they start over. So that one octave would be from A to A. And so basically in her study, she scrambled lots of different melodies between 3 octaves, and she noticed that those random octaves, they caused lack of recognition for the tunes that she did that for. And then some other people tested that. So Doling and Hollenbeek, they actually scrambled different melodies than she did. So she focused on Yankee Doodle and distorting that one a little bit, but still having the same notes and rhythms and stuff like that, but just making the octaves different. And then they focused on more songs like, they focused on Yankee Doodle, but they also had people recognizing that as the Star Spangled Banner or different things like that. So they noticed as well that this isn't just for one song, it happens for lots of different songs. And the scrambling of melodies can actually cause that lack of recognition for melodies. So truth versus reality. So creative expression is when the mind manipulates sounds. And when the mind manipulates sounds, that is basically our own mind creating our own personal sense of our reality. So reality of this kind of illusion is that the notes in the song, they're being played, like the right notes are being played. So when an A is supposed to be played, an A is being played. But since they're in random octaves, you're not able to necessarily identify the melody that's being played. So based on Michelin, Simmel, Dahmen, and Domini, melodies are recognizable when in those correct frequencies. So it's more recognizable when they're played the way that we hear them normally, rather than when they're distorted and randomized. And then the perception aspect, notes are actually recognized as being the song. So like what you're gonna hear is you're not gonna know what's going on, and then you're going to know that the notes in the song, like what song you're listening for, and then you'll be able to recognize that, and you'll be able to perceive that differently based on that. And so life experience actually influence that. Like I said, once you know what song you're listening for, then it's going to be a lot easier to identify what's going on. So materials, so I used a lot of different materials, but I'm just going to kind of skip into the methods and talk about the materials as I go through the methods and how I use them. So I obtained an unaltered music in a single octave of a specific song that I'm not going to mention because it'll ruin the illusion. So then I played and I recorded the unaltered music on the piano, just so I had like that bass line so I can show that to you. And then I transcribed that music into random different frequencies between 6 octaves on the piano. And so I taped the numbered slips. So this is in a single octave. This is the first, this is the actual melody. Don't try and decipher it. But basically I put the numbers on it because I'm not a pianist, so I just followed the notes. So I put 1 where 1 was supposed to go on the scale, and then it would go 1, 2, 3, 4, 5, like that kind of stuff. I'd follow the notes and the rhythms in that direction. And then for varying octaves, as you can see, it's spread across the entire piano. And this piano, the notes are all around. So I placed the same little slips of paper onto the different notes in that direction. If you need any more clarification about that afterwards, like how this all, like why I did what I did, I hopefully explained it a little bit, but it is very musical in that kind of sense. And so here's going to be my demonstration. So as you could tell, the notes were very random frequencies, right? There wasn't like a single note that was played back to back in the same octave. And so I'm gonna tell you now that that song was actually Old MacDonald Had a Farm. If you weren't able to recognize that, hopefully this next example is gonna help you hear what it should sound like, and then I'll play it again and you'll be able to hear it a lot better. Oh, this one. Hold on. Oh. And then we're going to listen to the unknown again, and you'll be able to hear those frequencies and those notes being played a lot better now that you know what song you're listening for. Hopefully you guys are able to hear a difference. So that's kind of that whole perception versus reality, and I'm going to talk about that. So some educational connections that I need to make for this presentation is that EDU 215, I took this as a humanities-based exploration course, and I basically discussed in the class that these things, that different things affect how a student does in school. So different things like home life, sleep schedule, health, multiple different things like that. And so I kind of focused on the sleep schedule aspect of that, what we talked about in that class. And so sleep deprivation, it alters the psychoacoustic performances found by those researchers. And so I found the relationship between it is that 30 to 36 hours of sleeping affects auditory processing. And so by not sleeping, these students might not be hearing as well as other students, and they might be perceiving things differently, kind of how we perceived those different sounds after knowing more information. And then this music, the arts and culture, it's an art foundation course. And this basically explained that there are different musical sounds that different cultures hear. And then different languages produce those different sounds. And so this sound perception, based on what you're surrounded by, you're going to be able to hear different types of sounds, and you're going to be able to perceive things differently than what you actually would have been able to. So this might have been easier for someone who's been exposed to Old MacDonald because of their culture, rather than to someone who hasn't ever been exposed to it before. So then the perception of truth and reality. So reality basically combines with imagination. So before, you were unable to imagine the song without with the notes being played, even though it was the same thing before and after I played the Old MacDonald song. And then after, you can imagine, so that's where that imagination takes place, and you basically imagine what it's supposed to sound like, and then you're able to identify it better, and you're able to relate those frequencies into where they're supposed to be, and your brain's able to hear it a lot better than it did previously. And then this is the same kind of effect that after listening to familiar songs, people can imagine songs in silence. So if you're thinking of a song and you can kind of sing along to it, that's kind of the same idea. You have that previous knowledge, so now you're able to imagine that song. So, and then the philosophy and reality kind of aspect of this is that your upbringing affects your perception of the world around you. Nurture versus nature, what you're brought up in, that's the kind of stuff that you're going to be able to use and perceive things differently from. And then the conclusion, so for distorted familiar sounds, they're difficult to comprehend. And so before, the octave jumps are the brain's main focus. And then after, you're able to focus more on the hidden jumbled frequencies. So you're able to focus more on what's going on. So sleep, language, previous knowledge, and upbringing affects your perception of sound, especially regarding the mysterious melody that I demonstrated earlier.